All right, so in this video, we're gonna work through example 2 here and example 3. Now our first example was a one-tailed test. It was less than. So in these problems, we're gonna deal with two other situations. In example 3, I really wanna make sure that we understand how we're gonna find the p-value when we're finding the probability that a certain value is greater than instead of less than. All right, so here in example 2, we have Harper's Index claims 23% of the people in the United States are in favor of outlawing cigarettes. You decide to test this claim and ask a random sample of 200 people in the United States whether they are in favor of outlawing cigarettes. Of the 200 people, 54 said they are in favor. At a 0.05 significance level, is there enough evidence to reject the claim? So the first thing we have to do is make sure that we know we can use the methods that we used in example 1 here. So I need to know what P is, what Q is, and what N is. So in this case, P is the historical claim, and that is 23%, so 0.23, which would make Q 1 minus 0.23, or 0.77, and N here is I sampled 200 people. So is NP and NQ, are these bigger than 5? So we're going to do 200 times P, that's bigger than 5. We're going to do 200 times Q, that's bigger than 5. So we can go ahead and continue here. I'm going to move this down just a little bit. So now, let's write out our null hypothesis. The null hypothesis is the original claim, and that is that 23% of people in the United States favor outlawing cigarettes. So P is 0.23. I have to write it as a proportion, not a percent. Our alternative hypothesis, we're trying to see if we can reject this claim. So what that would mean is that P is not equal to 0.23, and so this is a two-tailed test. So there's my null and my alternative hypothesis. So now I have to go about finding P, okay? The p-value. We already know what P is. P is 0.23. The p-value, the probability that we would get a proportion of people in this sample that is different from the original claim. That's the p-value. We're trying to find the probability that the 200 out of 54, which is my p hat, 54 out of 200, is 0.27. So this value is actually greater than the value that's being claimed here, 0.23. Now, I don't care if it's greater than or if it's less than the value. I'm trying to prove that the proportion that was claimed is not the proportion in actuality. So I gathered this sample and I got this p hat value. P is still 0.23. My standard error is going to be the square root of P times Q divided by N. So that comes out to 0.02975, blah, blah, blah. Okay. Now, because P hat is bigger than P, I want to know what is the probability that this value could be this much bigger than the mean. So I'm going to find the probability that P hat is greater than 0.27. I don't want to do less than, because less than is very probable. I know that it could be less than 0.27 because the claim is that it's 0.23. So if we're assuming that this is true, we are trying to find what's the probability that I could be this much bigger than the claim. Now, if I'm finding the probability that p hat is greater than 0.27, I need to do 1 minus the probability that p hat would be less than 0.27. Because of the way that the norm.dist function calculates probabilities, it's always going to do less than the value. So if I want greater than the value, I want to do 1 minus that. So I'm going to do 1 minus norm.dist. And that's going to be this value, comma, this value, comma, this value, comma, true. This is going to give me the probability that I could just randomly select a sample of people and get a proportion that's this much bigger than the historical 0.23. Is 0.27 statistically significantly bigger than 0.23? Let's find out. We get 0.08944 as my probability, but this is a two-tailed test. That's the probability above the mean. We need to multiply this by 2 to get my p-value. I need to multiply this by 2. So I'm going to take this value and multiply it by 2. So now we're up to 0.18 as a p-value. That is greater than 0.05. Even 0.089 was bigger than 0.05. And so we are going to fail to reject the null hypothesis. And so Harper's index, the claim that they made, there is not enough evidence to reject the claim that 23% of people want to outlaw cigarettes. I just don't have enough evidence to say that what Harper's index claimed is wrong. I'm not saying that it's right, I'm just saying that we don't know that it's wrong. And that's it. There's not enough evidence. Now, if we had done this differently, if we had chosen a significance level of 0.2, then we could reject the null hypothesis. But then we have 20% of uncertainty, and that's not great. So now, let's create a 95% confidence interval to just solidify the fact that we failed to reject the null hypothesis. I should expect to capture the historical p-value in my confidence interval for this problem. So to find the lower bound, and this was a two-tailed test, so my 95% is going to be split. The extra 5% is going to be split between the lower tail and the upper tail. So my lower bound is norm.inverse. My proportion is going to be 0.025 for the lower bound because I want 2.5% on the bottom end. My mean is p hat, and my standard error is the 0.0297. So my lower bound is 21%. 21.2%, okay? Notice how 23% is larger than 21.2%. My upper bound is going to be, again, norm.inverse. The probability here for the upper bound is going to be 0.975. Now there's 97.5% below this value. The mean is still p hat. The standard deviation is my standard error, and that gives me a value of 0.33. And so if Harper's Index had claimed that 30% of people in the United States are in favor of outlawing cigarettes, the sample that I took can't refute that. We're saying that 95% of the time, based on this sample, we should get a population proportion that's between 21% and 32%, almost 33%. So yes, this still captures the mean. This confirms that I should not reject the null hypothesis. Does this prove that Harper's Index is correct? No, it just tells us that we shouldn't think that it's incorrect. All right, let's do one more example. The Pew Research Center claims that more than 55% of adults regularly watch a network news broadcast. You decide to test this claim and ask a random sample of 425 adults in the United States whether they regularly watch network TV. Of the 425 adults, 255 respond yes at a 0.05 significance level. Is there enough evidence to support the claim? So the claim is 0.55, which means that Q is going to be 1 minus 0.55. And in this case, we sampled 425 people. So that's giving me confidence that my NP and my NQ are going to be larger than 5, because N times P is 233, and N times 45% is 191. So I can go ahead and use the methods that we've been using. My null hypothesis is going to be that P is equal to 0.55. My alternative hypothesis is, we are trying to support the claim that it's greater than, so the claim here is that it's greater than 55%, so P is going to be greater than 0.55. The way this is worded, the Pew Research Center is claiming this, so we are going to see if that is indeed true. So we are saying, okay, it's greater than 0.55. So historically, it would be 0.55. That's what we're testing against. So now we need to find our p-value. So we need to find p hat. We know what p is, and then we also have to find our standard error. So p hat is going to be the 255 adults divided by 425 that I've actually surveyed, which comes out to 0.6%. My P is 0.55, and my standard error is the square root of P times Q divided by N. So we're looking for the probability that P hat is greater than 0.6. Did this value come from regular statistical variation, or am I able to, is getting a sample of 0.6 so impossible that I have to say that I don't think 55% is the number. I think it's more than that. So that's what we're asking ourselves here. So since this is greater than, we're going to do 1 minus norm.dist. We're going to use p hat for x. We're going to use p for mean. And we're going to use my standard error for my standard deviation. True. And I get a value of 0.019. This is a one-tailed test. And so since this is less than 0.05, that means that this is so rare that this would happen that we must reject the null hypothesis. So I think what has been tripping some people up is sometimes this number is so small that it writes it as scientific notation. So if I were to write out something like you'll get scientific notation. So if you see a negative number after the E, that means that in this case there are 11 zeros. There's a decimal point and then there's 11 zeros before the number. So if you see something like this, that doesn't mean that this number is bigger than 0.05. It means that it's smaller than 0.05 or 0.01. So here we're going to reject the null hypothesis. What does that mean in the context of the problem? There are more than 55% of Americans that watch network news. Or we can say there's enough evidence to say to support this claim. Is enough evidence to support the claim that there are more than 55% of Americans, or that more than 55% of Americans watch network news. So we have enough evidence to support the claim that it's more than 55%.